In this lesson, we're going to continue talking about electron configuration, and what we're going to do today we call shorthand notation. So in the last lesson when we did orbital filling diagrams, drawing out those diagrams was considered the longhand version. Today we are going to do what's called the shorthand version. You will need your resource packet for today's lesson, and you need to flip to the page that says electron configuration, and you're going to see these two diagrams. So first, let's start with the steps for writing electron configuration. So step number 1, you need to determine the number of electrons. To write an electron configuration, we need to know how many electrons to account for. Step number 2, we are going to follow the Aufbau principle, which states that the lowest energy levels are filled first. So we are going to use the resource packet to determine the order orbitals will fill. So I like the diagram on the bottom. I think it is easier to read. Energy increases as we go up. So that means orbitals at the bottom have lower energy. So if we're going to write our orbitals in order of increasing energy, we would start with 1s, and then 2s, then 2p, 3s, 3p, all the way up. So the way that you determine which orbital do you start writing, which one is the lowest energy, just start at the bottom and energy increases as we move up. Step 3, we are going to fill the orbitals with the appropriate number of electrons. So remember from last lecture, we said that an s orbital can hold a maximum of 2 electrons. Once you get to a p orbital, p can hold a maximum of 6 electrons. D can hold a maximum of 10 electrons, and F can hold a maximum of 14 electrons. So we're going to start with the lowest energy orbitals, and we are going to fill them with the maximum number of electrons. We are going to continue adding orbitals in order of increasing energy until the sum of the exponents equals the number of electrons from step number 1. So let's do a few of these together. Let's say you were asked to write the electron configuration of, and we'll do a few of these together. First one, let's do fluorine. So the first thing that we need to do is go to our periodic table and we need to find fluorine. Fluorine is atomic number 9. That means fluorine will have 9 protons. As an atom, it also has 9 electrons. Step 2, we're now going to go to our resource packet to determine the order orbitals will fill. The first orbital that is going to fill is the lowest energy orbital, which is 1s. Step 3, fill the orbital with the appropriate number of electrons. S can hold 2 electrons, 1s2. Once the 1s orbital is filled, we're going to go to the next orbital. So let's follow the arrow up. The next orbital would be 2s. And again, s can hold 2 electrons. So far, we've placed 4 electrons. We have 9 to go, so we have to keep going. After the 2s is filled, we go to 2p. P could hold a max of 6 electrons, but remember, we only want to place 9 electrons. We've already placed 4, so this would be 2p5. So our last step is we just want to make sure that the sum of the exponents equals the number of electrons. So I have 2, 4, 9. So my electron configuration for fluorine is 1s2, 2s2, 2p5. Next, let's do aluminum. So if you look up aluminum on the periodic table, aluminum is atomic number 13. So an aluminum atom has 13 protons and 13 electrons. We're going to use our resource packet to determine the order that the orbitals will fill. We are always going to start with the lowest energy orbital, which is 1s. An s orbital could hold 2 electrons. Once the 1s orbital is filled, we're going to go on to 2s. And again, s can hold 2 electrons. Once the 2s is filled, we're going to go on to 2p. P could hold a maximum of 6 electrons. So far I have 6, 8, 10. I have to get to 13. We're going to keep going. Once the 2p orbital is filled, we're going to go on to 3s. And again, an s could only hold 2 electrons. Right now I'm at 12. I need to get to 13 electrons, so I'm going to keep going. After 3s comes 3p, and aluminum would be 3p1. Last step is just to count our exponents, make sure they equal 13. 2, 4, 10, 12, 13. So we're good. Let's do iron. If we look up iron on the periodic table, it is atomic number 26. So that means iron has 26 protons. It also has 26 electrons. Again, let's start with our lowest energy orbital, which is 1s. S could hold 2 electrons. Once the 1s is filled, we're going to go on to the 2s. And again, an s orbital could only hold 2 electrons. Once 2s is filled, we're going to go on to 2p. P could hold 6 electrons. So far we've accounted for 10. Once 2p is filled, we just keep going up the ladder. After 2p comes 3s. And again, an s orbital could hold 2 electrons. After 3s comes 3p. P could hold 6 electrons. 2, 4, 10, 12, 18. Let's keep going. After 3p comes 4s, and again, s could hold 2 electrons. We're at 20, and we need to get to 26. After 4s comes 3d. We haven't done a d orbital yet, so let's look back at our steps. D could hold a maximum of 10. But in this case, we've already placed 2, 4, 10, 12, 18, and 20 electrons. I need to get to 26. So I'm going to end in 3d6. Lastly, let's do an ion. Just like with the orbital filling diagrams, electron configurations for atoms and ions, we're going to do them the exact same way. The only difference is that the electrons will be different. So if we look up calcium on our periodic table, calcium is atomic number 20. So as an atom, calcium has 20 protons and 20 electrons. But if calcium has a charge of +2, that means that it has 2 more protons than electrons. If calcium has 20 protons, and it has 2 more protons than electrons, that means that this calcium ion has to have 18 electrons. Again, calcium has 20 protons, so that would be 20 positive charges. If it has 18 electrons, that's 18 negative charges. That's going to get me to that net charge of +2. But once you know the number of electrons, we're going to do atoms and ions the exact same way. So we're going to start with the lowest energy orbital first, which is that 1s orbital. S can hold 2 electrons. Once the 1s is filled, we go on to 2s. And again, s can hold 2 electrons. Once the 2s orbital is filled, we go on to 2p. The p orbital can hold 6 electrons. So far I've placed 10, we have to get up to 18, so let's keep going. After 2p comes 3s. And an s orbital could hold 2 electrons. Going up in energy, after 3s comes 3p. P could hold 6 electrons. Last step is just to do a quick check. Make sure your exponents equals 18. 2, 4, 10, 12, 18, so we're good.